Operation on linked list is insert a new node at the front of the list, append a new node at the end of the list, insert a new node after a particular node, and traverse the list from the beginning. Delete a node at the front of the list, delete a node at the end of the list, and delete a particular node. Right? Then there is another operation like reverse the list, reverse the list. Fine. And there is another operation called um, split the list in two halves. Split the list in two halves. The list in two halves. And yeah, these are the basic operations which you need to perform, or you can perform a search. This is basically expensive operation, so
So
we don't
you
like
mean
to.
like expensive operation?
Means it will take time to reach that part. So we try to avoid the expensive operation. We have to use a vector or array for search operation instead of using linked list. Fine. So we go back to code blocks and we try to write one linked list program which can perform all these operations. So here in this code, I have created a node. Here in this code, I have created a so here I have created a node, right? And I'm using the template also here, right? So that we can provide any kind of data in the data part. Okay, you can provide any kind of data in the data part, and I'm creating a function called create node, right? And this function is going to return create a node. This function is going to create a node like this, and it will create the data part and address part. It will create the data part and the next, and in the next null will be stored here, and in data some data will be there. Some data will be there. It can be anything. Okay, and the address of this node is going to be returned. So say for example the address of the node is 1b2c, and this address will be returned. Fine, and this address is currently pointed by t. This address is currently pointed by t, so I am returning the t. Okay. Then I have created a function called get data. Then I've created a function called next node. Then I've created a function called get next node, and then I've created a function called get current node. Okay, so these are the things I have created, and these are the methods. You can see that this is a get data function. This is the set next node function. This is the get next node function, and this is the get current node function. In current node function, I am returning the this pointer. Okay. So in C++, this is a pointer, not an object. Okay. So here I am using this, and it always points to the current object. So I need to return the current node, so I am returning here this. So these methods are the required methods for a node class. Okay. So now I'm going to use the node class and create a class called linked list. Okay. I'm here, and I'm going to create the class called linked list. Writing here class list class um, private uh, R, and we call it head node. Head node. Okay. So this head node is always going to point to the first node in the list. Okay. So what we can do here, okay, we can keep the two pointers inside our linked list. Right? and that helps actually. Okay, so say for example, if this is our list, right? If this is our list, and you can think about trains also, right? You can think about a metro train, right? Metro railway. So metro railway has two driver position, one driver position here and one driver position here, right? This so this driver position is pointing to this one, right? It's pointing to this node, and this driver position is pointing to this node. Okay, so this is called head. Let me call it start instead of head, and that will be easier. Start will be easier. So we call it start, and this we call it end, right? This we call it end. In few books you will find that they are using the term head and this term as tail, right? Head or start or tail or end. Fine. So this is how linked list is being created. Okay. So if I have to do insert at begin, what I have to do? I have to adjust the head pointer. And if I have to do insert at end, I have to adjust the tail pointer. I don't have to visit the list to reach till the end, and then I can attach, which I was doing in the previous class. Nashatanik?
Yes, sir.
Rushil, you have watched the video. That is what I am doing. I was traversing through the list, and then I am attaching. So, for example, if my list contains 1 million objects, then what I have to do if I have to add it at the end, I have to traverse 1 million. Now, and if I have a pointer which is pointing to the end, then automatically at one operation I can add my object, right? So that will save a loads of time, right? And it will take hardly 1 milliseconds to solve my problem. Okay, so generally in a competitive programming you will get 1000 milliseconds, right? So what is 1000 milliseconds, Rushil?
So 10 seconds.
1000 millisecond is
For 1 second.
So much.
1 second. 1000 millisecond is 1 second. So maximum execution time of your program should be 1 second,
1 second.
right? So you have to be careful regarding this, right? When how you are writing the code. Okay.
Yeah.
So what we are going to do here, in this case, we are going to create two pointers, right? So one pointer name is head and another pointer name is tail.
Yeah.
On star head and tail. Okay, that's it. So we are going to create two pointers, head and tail, and we can create it in the same line also, right? So many of my students ask me, sir, why are you creating two lines? Because professionally, when we write program, we create one data type, one variable, one data type, one variable. So that is my habit. But generally, students' habit is like that. Ki, sir, let me write it all the variables in one at one line. So they think that my program is shorter, but actually it is creating two lines after compiling. So this is the node star head comma star tail. Okay, and here we need methods. Okay, and what we can do here, we can put the templates on also. We need it. So template. We put here T because we are using the same thing in the previous class also. We will be needing it over here also. So public, and then we need a constructor of the linked list. We write here linked list. We put on a bracket and we write here head equal to equal to, and then we put here. So this is the linked list constructor. So it assigns a head and tail, both will be null. Now what we do, we write down the method. So we write here void add node at at node at head, at node at head. Write the we write this method, then we write void add node at tail. And we provide some data also. So t data. So let's put here t, and we write here void insert node after. Here we provide node start, and we provide the t. Right here void add. So we have written this thing, and go to this. So traverse, void traverse. Right here node start. We pass the start node and we traverse. Or we can use, we have the head node, we can use it, so we don't have to pass anything. So void traverse, and
Like will we just pass the head node and the tail node?
yeah, head is there already. Head is already there in the class, so we don't have to pass it. Right. So we go right here, delete node. So you write here void delete node void delete at tail, void delete node, void delete node, and you pass here the data, right? It will search and delete that node. Okay, and this is expensive operation. Because here also you need to search for a node and then delete. Okay, and if the search is unsuccessful, then you have to say that not found, node not found, that kind of thing. Delete a particular node, reverse the list, void reverse list. Then we have split the list, void split. Here you pass down node star comma node star. In these two lists, your data will be, these two are the head. So you pass double pointer. Your list will be separated into two halves, and these two are the header of those two lists. Okay. So this is the thing, and split is there, right?
So you are told the traverse. So I mean, so why will delete node become an expensive operation?
Delete node is an expensive operation because we need to perform search. We are not deleting it from head or tail. We are performing a search for a node, and if the search is successful, and then we are deleting it.
Okay,
So that is why it is an expensive operation, right? Search means it will take time, right? Search means time, and whenever
Yes.
you have to invest time, it is an expensive operation. Okay, so this is the split, and search is you can write here search also. So void search node, and you can perform the search by passing one data. So this is also expensive operation. Okay. So now we write a few of the methods, and let me show you okay, how this thing is working. Okay. So first is add node at head. So we write here void add node add. Here we put t, and here we have to use some special syntax. Right? We have to write linked list, and here you have to write p, and you have to write scope resolution operator. Okay. In this way, you can write down the method outside the class. Right? And here you have to write down the template thing also. Every time, whenever you write down the method outside the class, the template, keep name, type. Here we are using T, so T data. And now what we do here, we create a node, right? Node, node of type T, and we put a star here, star node is equal to, so we need to allocate the memory, right? So we write here new node. Now what we do here, we write, or we can call the method also. We have the method, use that method. Node T star node, and what we can do here, we can write a method. Mm, node node arrow, then there is a method called create node. Okay, and in the create node I have to pass the data, so the node will be created for me. Fine, now I have to check if head, right, if head is null or not. If head equal to null, that means that this is the first node, right? Simply I will write here head equal to node. Right here return. Fine. Inserted my first node in this way. Okay, so first I have created a node, and then I have added that node under head. So the drawing will be like this. Here, drawing is very much important. First, first your head is there, and head is containing the null. Fine, this is head node. And then what is happening? I am creating a node here, right? This is the node with some data or something, and the address is there 0x say 2150. And what I'm doing, if head is null, then I'm assigning this 2150 to head. So head, the content of the head is 2150, the content of the head. So that means head is pointing to this node. So this is the content of this head. Okay, and this is attached. So now we have another variable also, tail, right? But tail is also null, right? So tail will also point to this node. So the content of the tail will be 2150. Got my point? So head is pointing to this node, tail is also pointing to this node.
Yes, sir.
Okay? Because this is the first node. So what I have to do, I have to write here. So I have to write here head equal to tail equal to,
no.
right? So it is being attached. Now again this function is being called linked list add node at head p data. So this is again called, so it will create another node, right? So it will create another node. So a new node is being created. A new node is created. So let me see, this is a new node. So this is 3250. So this new node is created, and now I have to see my code. So in my code I have written if head double equal to null, head is equal to tail equal to node. But this condition is false. So it will come after the if block. Okay. Then I have to do few adjustments, right? So what are the adjustment I have to do? Fine. So the adjustment is like this. Okay. I have to adjust the head node, right? So I will adjust like this. Okay, node. So my current node is this. My current node is this.
This.
So what I will do, I will try to point this node, right? I will try to point this node. I will try to point this node, and my head node is going to point this node. Got my point? Then this node is attached to the list. Fine.
Yes, sir.
Okay.
Yes.
So I have to what I have to do in the next part. In the next part, I have to store 2150. I have to store 2150. Okay. So how to do that? So let me go there, and I will write here node arrow arrow. Then you can see that get next node. Where is the set next node? There is a function called set next node, right? In the next node, what I will do here I will put the head, H-E-A-D, head, right? So the address of head will be set to the next node, to the next node, right? That means the address of the content of head is what? The content of head is 2150. So 2150 is here. So that means this node started pointing to this node. So now I have to update the value of head. So what I will do here, I will write after this. Head is equal to node. And I don't have to I don't have to set anything for tail node, right? Because now there is a new picture. So the new picture is when I've written that statement, this is updated to 3250. So now I have new picture.
But then
So
the tail would be pointing to 215. Yeah, yes.
0. Tail is 2150. So this is pointing to this node, right? 3250, and this is pointing to 2150, and this node is pointing to 2150, fine, and tail is
It's,
pointing to
it's pointing to 2150.
150. So now this is head and this is tail. I hope this idea is clear to you people.
Yes, yes, sir.
Yes, sir.
Hmm. So in this way we have added the node by using add node at head. So this function is finished. Now let me write down the next function. Then I will be writing add node at the end. It is also very much similar. The code is node at tail. So I have to create the node. I have to check whether the node is null or not, right? You have to see, you have to go through the similar situation over here also when this is the process for add node at head. Now we go to another part of the screen and here we write add node at tail. Okay, so what will happen ke first time the both the pointers, head pointer and as well as tail pointer, both are null, right? Both are null. Then now what you have to do, you have to add a node from the tail, right? But as such there is no node, so we have to create a node and we check this condition ki if head equal to node null, that means ki there is no node, right? So we can assign head is equal to tail is equal to node. So we have created a node first, we have created a node here first, and this node, so this node has address 100 and this node is created and this node is pointed by head and tail both 100 and this is pointed by this. So this will also contain. Now this function is called again and we have created another node here, okay, and the address of this node is say 200, okay, and I have to attach this node at the tail, right, at the tail, okay. Then what I have to do, so tail is already pointing to this node, tail is already pointing to this node, so this node next part is null, this node, this is the next part, right, this next part is null. So what I have to do, I have to attach this 200 to the next part of this, okay. So how to do that? So for that what you have to do, you have to write here, you have to write here tail, you have to write here tail, tail, tail arrow set next node, set next node, and instead of head we write here node, we write here node, okay. So when you write this statement, what will happen, this 0x200 will be stored here, 0x200 will be stored here and this node starts pointing to this node. Now our job is to shift this pointing, shift this pointer not from here to here, right? So we write the statement here tail equal to node and we are done.
So it should be tail equal to node, right?
Yeah, we write tail equal to node. That means when you write this statement tail equal to node, then this address, this 0x200 will be here.
Point to.
Instead of 100 is 0x200 is here. So now this is pointing to this instead of pointing to this node. Okay, got my point. So now you have a newer picture like this. So this is 100, this is a head and it's pointing to a node. This is 100 and this is pointing to another node that is 200, right, and this tail is pointing to 200. Got my point? So we have added node at the end very easily without using any loop, right, and without traversing the list also. Okay, got my point? So
Yes, sir.
this is how add node at tail works. Okay, so we have written add node at tail. So now let me write down traverse function, right? So we use the traverse function. list. So now you write down here node star star equal to head. Okay. And you write here while start start right here cout star get. He give us the data and that data will print. Okay. Uh, we write here one arrow here. Then we and go here. We write here start is equal to start arrow get next node. Get fine. So the pointer will move. And here we print a message here. Cout list. Semicolon. And here we check first. Okay, the traverse function is called if we have a list or not. Right. So we check here if head is equal to null. Right. That means that there is no list. So we print the message cout. Right here return. List is empty and we write there return. And otherwise we visit the list. Here we write down cout handle. Okay, so this is the traverse function. So let me write down the delete function. So here at head.
Delete node add.
Here, right here template. Name at head. You have to do few things like the list. Right here. So first thing you need to check whether the list is empty or not. So you write if head
Is equal to null.
print the message cout slash list is empty. List is empty and then you write down here return. Okay, and you will write down the message. Okay, people and list is empty. Here, if list is not empty, then what we have to do? We have to delete the node. So to delete the node, what is the idea? So delete node at head. So if we have only one node, right, and we need to delete this node. So this is head, and this is, say for example, this is 100. This is containing 100, and this is also containing 100. This is head, and this is tail. So first thing, what we have to do, we have to assign this node to to a temporary node, right? To a temporary pointer. Fine. So we write here node star, node t star, say temp is equal to head. We have assigned the node, the head node, right? And then what we do, we write here head is equal to head is equal to we write head arrow, right, get next node, get next node, right? In this way, um, so if null is stored there already, here we have null, here we have null. So when I have written this statement, automatically null will come down here, automatically null will come down, right? And we need to check after that whether head is null or not. If head is null, then tail must be null. Okay, here after this we need to check head if head double equal to null, then we write here tail is equal to null. So we need to make both null, right? And after doing this operation, right, after doing this operation, we delete the temp node, right? Delete temp. Okay, so we have to write here delete temp. uh, delete the pointer directly, I think. Let me check once. Delete star temp I have to write, or delete temp. Got confused with few languages. For array it is using this symbol, but for pointer I think delete pointer, right? So it is correct, so it will work fine. So it will delete the temporary pointer. So this is how delete node at head works. Okay, so let me go to the main function and create the linked list. Okay, we create the linked list here, linked list, and this list is of type. So for the sake of the simplicity, I'm keeping it as integer. Okay, we write here list link or link. Okay, object. Now we write here while and one, and we write down all our cases. Okay, case one. Uh, what you can do here, you can print the menu. Right? Cout /n press 1 to add node at head. Here we can write it down. Press 2 to add node at tail. And press to traverse the list. Traverse the list. First, press 4 to delete node from head. Node from head. And press 5 to delete uh, press 5 to traverse. Press 5 to traverse. Because I have written only this 5 function. Press 5 to traverse. Here you write down cn ch. Here you write down switch. And inside that you will write down the cases. So you declare a variable here also integer of ch, and we can use it. We can declare other variables, say for example data. So here you write down cout. You create an input function also.
Sir, I will just bring some water and will be back.
Yeah, okay, no problem.
So also, sir, I had a question. Like while one answer, like can't we just write while true as like if we want to?
Here one means true.
True only, right? So that's what I'm asking. So.
In C++, one will be true, and in Java we have to write true, true, true. Cn cout any number, and then here you write down cn and d. All the function. Here ll dot add node at head, and here we provide the input. It can return the information. I just write down the input. I don't need to put any variable here. Cnd return d. That input will be provided here. I don't need to create this variable.
Sir, but D needs to be declared, right?
Yeah, d needs to be declared, right? That is true. Declared d.
You haven't declared the.
I declared it inside the method because I need input function in many you people, because rest of the function is implemented by you people. So this function will help you out because you have to write multiple times a similar kind of a code. So I factorized that part, right?
Yeah.
So this is the input function, and yeah, so it will create the node, and we write here break. Right here, case 2 is add node at the tail. So ll dot add node at the tail, and again I have to write input function. This is quite helpful. So, and you can write here break. Case 3, we traverse the list. So I just write here ll dot traverse 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 the list, and break. And then I call the delete. Oh, I have written traverse the list 2 times. Delete the node from head I have written. That means I have written
Yes.
only 4 functions. So here instead of this, I can write here enter your choice. Enter your choice. A feeling that I've written 5. 1, 2, 3, and 4 method. Traverse, and 4 is delete node from head. Case 4, uh, ll dot delete node from head. And other thing is that I have not printed any information here, right? So if I'm able to delete the node, it's better option I print the information. Okay, cout slash n head node. Here I will write temp arrow get data get data. Printed the information here. So delete node, add head, and then break. Then here default, and then write down here cout slash n. Wrong option selected. Wrong option selected. Close this. Put the semicolon here. Here, this is the end of while. This is the end of. This is the end of switch. And I need another choice to exit from the loop, or to stop the program. So slash n, press 0 to exit from the exit, 0 to exit, press 0 to exit, semicolon. We need a case 0 also. So we write here case 0. We write here we put here choice. So for exit, you have to write here hash include stdlib.h, required for exit. Save this code. Let's save this code, and we try to compile the code first, then we execute. Node, what is the problem? Template type node must be followed by the simple declarator ID. Node, yeah. give it here and compile it. So error 14 line node where I have missed. Let me take the help of compiler. Line number 55 here. And I have to put here. Okay. Let me take the help of the compiler once more. Okay. Where it is? Comma or semicolon expected 85. 85. Yeah, semicolon is expected here. That's true. Let me take another help from the compiler. Expected semicolon at 122. There. Yeah. Semicolon. No matching call. Linked list add node at head. T as int. Node candidate void linked list with t equal to int. And input is what? Input is returning integer, right? Maybe some problem. Let me clear a variable here. It's better to clear a variable. Integer d is equal to input is equal to bracket here. So we got the integer here and we put here the problem over there also. So same thing here also. Here put D. We this one.
Redeclaration of D is
Oh,
causing the problem.
yeah, I understood. Let me remove the read declaration. This is actually bad practice. I always say to my students that bad practice. Okay, add node at head. It's a problem. Add node at head with t as an int. No matching function for call.
So can you go to the add node at head declaration?
I'm going to that part only. Add node declaration. Node. This is the node at head declaration.
Yeah.
So T arrow data.
Don't you have to write a name?
No,
Oh, no.
I have to write any variable because I'm
Yeah.
writing it here.
Yeah.
Writing it here.
Yeah.
I want to keep it. They're saying that it is T is int, right? So I'm passing their int variable. What they are saying. 134 number line. See out I have used STD. Yeah, I have used STD. Saying that this operator is not met.
So get data is missing the parenthesis.
Get data is missing the parentheses. No matching function call add node at head. And that is 138. But add node at tail is fine.
It is in case 4. Instead of the delete node, you wrote add node at head.
Oh, sorry.
I see. I'm not trying.
Oh, I was looking at wrong place.
Yes, sir.
Node. Now it is fine. Now we can execute this. So add node at head. First, say for example, I've tried to traverse the list, and as such, there is no list. It has shown me empty list, right? And number 4, I try to delete the head. Fine, so list is empty. It has not deleted. So these two operations have worked properly. So now let me add the node. So enter any number. So I've entered here 100. So 100 is added. Now I want to add after 100. So I have 200. So 200 is added. And now I want to see the list. So you can see 100 and 200 is there. Okay. So now I want to add before 100 because I have a number called 75. So that is why I have entered here 75. Now if I press 3 to check whether the 75 is inserted at the head or not. Now I have another number called 250, right? Here, 2, 5 and 0. You can see that okay, 250 is added at the uh, end. So now let me delete the nodes one by one. So let me put 4 here. So 75 is deleted. Let me put 4 here. 100 is deleted. Let me put 4 here. 200 is deleted. And let me traverse the list. So traverse. 250 is left, right? So let me delete that also. So 250 is deleted. Now, now let me try to traverse it again. So it is showing list is empty. So these are the situations where the whole stuff is working, fine. And now I press 0, so it stopped. The code has stopped properly. So this is the code, and I did a very silly mistake here. Delete node at head, and here I have used instead of add node at head. So for that reason, it is producing that error. So this is the code, and the rest of the code, you people will try to write down the rest of the methods. Say for example, I have not written insert node after, so you have to write it with your own. You have to write the function delete node tail. You have to write down the function delete node. You have to write down the function reverse the list. You have to write down the function split the list into two halves, and you have to write down the function search node.